Hello my dear students, good morning. Now we will discuss about the ionic product of water. So it's a continuation for previous. So ionic product of water means we know that Kw. What is Kw means? Ionic product of water. Okay, so it's very clear. It is a product of ionic product of water means I am telling you it is the product of concentration of proton and hydroxide ion. Proton means H plus. Otherwise, it is the product of concentrations of what? Concentrations of hydronium ion. Hydronium ion means H3O plus and OH minus ion. That is called hydroxide ion. So, what is ionic product of water? To understand, water will undergo self condensation, self ionization. In self protonation happen. So one will donate proton to other. This water molecule will donate proton to this, like that. So you will have like H3O plus OH minus, like this you are having. H3O plus is called hydronium ion and this is OH minus ion. So what you have as we call K equilibrium, so we can call it as concentrations of products by concentrations of reactants. So this we can write as concentration of H3O plus and concentration of OH minus, and denominator concentration of H2O. This is H2O concentration, this is also H2O concentration. So you can write concentration of H2O whole square, you can write. This K equilibrium only we can write as Kw, because W means water. So this is the ionization reaction of what? Water actually. So it is equilibrium reaction. So what you can write now, therefore Kw is equals to concentration of H3O plus and concentration of OH minus simply. So this is Kw. Kw is concentrations of product concentration, because here into you have product concentrations of H3O plus and OH minus. It is the product of concentrations of hydronium ion and hydroxide ion, you can write. So you can write it as Kw is equals to concentration of H plus into concentration of OH minus. H3O plus is nothing but, everybody knows, H2O day 2 bond with H plus. So water is neutral, so H plus. So this is only called H3O plus actually. Combinedly, what this is called? H3O plus. So H plus concentration only you will have, because water is neutral. So H3O plus is nothing but H plus. So at 25 degrees Celsius, Kw has a value, it is 1 into 10 power minus 14. This is called ionic product of water value at 25 degrees Celsius, room temperature. This you can write mole square per liter square. Mole square per liter square. Very, very important. So one more important thing is here. As temperature increases, then Kw value will increase. As temperature increases, then Kw value increases. This is very, very important. Why, sir? Because as temperature increases, this ionization, self-ionization can increase. So that's why if self-ionization if increase, certainly these concentrations will increase. So if these concentrations increase, then Kw value increase. So that's why as temperature increases, then Kw value increases. Very, very important thing. So for neutral solutions you can write. This is Kw value. For what? Neutral, here you can't see, I think so. So bit down and right. So for neutral reactions, neutral substances, for neutral solutions you can say, for neutral substances you can say, concentration of H plus is equal to concentration of OH minus. Correct or wrong? Yes. Then for neutral solutions, what you can write? Kw is equals to concentration of H plus whole square, or else Kw is equals to concentration of OH minus whole square, or else you can write. Correct? Huh? So Kw value, you know, that is 1 into 10 power minus 14. I am considering these reactions at room temperature. Certainly you can write this concentration of H plus whole square is equals to 1 into 10 power minus 14. I can write. Therefore, concentration of H plus is equals to root will come here. So root 1 into 10 power minus 14. So you will have 1 into 10 power minus 7. Similarly, what you can write? Similarly, okay, concentration of OH minus also you will get 1 into 10 whole square is equals to 1 into 10 power minus 14. I will write directly. So this is also 1 into 10 power minus 7. Okay, for what? Concentration of H plus and concentration of OH minus. For what? For neutral solutions. So what you can write therefore? Concentration of H plus is equal to concentration of OH minus is equals to simply 10 power minus 7. This is for what? For neutral solutions. For what solutions? Neutral solutions. Very, very important. So please have a look for neutral solutions. For neutral solutions, neutral means what? How much H plus ions are there? Those many OH minus. Acid combines with base. Okay. If concentration of H plus is equal to concentration of OH minus, then only you will have complete neutral solution. Okay. So when neutral solution we are considering, then H plus ion concentration and OH minus concentrations are equal. So as I said, Kw, it is a product of both. So instead of H plus you can write OH minus, instead of OH minus you can write H plus. Okay. So Kw is equals to concentration of OH minus whole square you can write. Otherwise Kw is equals to concentration of H plus whole square you can write. So very clear. So both you can equalize to that ionic product of water value 1 into 10 power minus 14. So very simple. Please remember this much, enough to you, because now we are not writing any board exams like that. So simply these are important for you. You are going to write only NEET exams like that. So if you remember, this is enough. But how we got this? This is the way. Concentration of H plus is equals to concentration of OH minus is equals to 10 power minus 7 for neutral solutions. Have a look and write out this. Okay, very, very important. Next, the most important thing is what for acidic solutions and basic solutions, how we write. So now for acids, what you have? Acids means what? H plus concentration is more. Everybody knows. So for acids, you can write for acids concentration of H plus is greater than concentration of OH minus. Correct? Huh? Concentration of H plus is greater than concentration of OH minus. Therefore, you can write for acids concentration of H plus is greater than 10 power minus 7. Because equal actually. Concentration of H plus is equals to concentration of OH minus is equals to 10 power minus 7. But here concentration of H plus is greater than OH minus concentration. Or else you can write like this. Concentration of OH minus is less than 10 power minus 7. Both are same now. Okay. So concentration of H plus is greater than 10 power minus 7 for acids. That is what you can write. What will be concentration of H plus for acids? You can write from 10 power minus 7 means less than 10 power minus, greater than 10 power minus 7 means 10 power minus 1, 10 power minus 2, 10 power minus 3, 10 power minus 4, 10 power minus 5, 10 power minus 6. And these all comes under what? Acidic concentrations. So what about the values? Concentration of H plus values between 10 power minus 6 to 10 power minus 7. Between 10 power minus 6 to 10 power minus 7 also weak acid. But exactly 10 power minus 7 neutral. 10 power minus 6.9 sir, almost neutral but slightly acidic like that. Up to 10 power minus 7 means less than, greater than 10 power minus 7 values comes under what? Acidic concentrations. Very clear. So for acids, these are the concentration. Concentration of H plus values between 10 power minus 6 to 10 power minus 7. Between 10 power minus 6 to 10 power minus 7. Like 10 power minus 6.4 suppose. 10 power minus 6.8 suppose. This all comes under weakly acidic. See, 10 power minus 1 is a greater value or not? Tell me. Okay. So concentration of H plus is greater than 10 power minus 7. One more important thing, from here, from 10 power minus 7 to 10 power minus 8, concentration of H plus what's happening? Decreasing. That means acidic character decreases. Okay, so once on X acid, Y acid. X acid has concentration of H plus 10 power minus 2 and Y acid is X acid. Here concentration of H plus is 10 power minus 4. So which is big? 10 power minus 2 is big. Mathematically you know 10 power minus 2 is big than 10 power minus 4. Therefore you can say concentration of H plus is greater than concentration of OH minus. That's it. Got it clearly? So concentration of H plus is greater than concentration of OH minus, you can say. See why here I am telling this again. Here acids means H plus concentration should be more. So here these are H plus concentrations. So here concentration of H plus, here if you see 10 power minus 2, 10 power minus 2 is greater than 10 power minus 4 concentration of H plus. Okay, that means X is a strong acid than Y. Acidic strength is more for X, like this you can write. So same way you can apply for bases. So this is for what? Acids. Concentration of H plus is greater than concentration of OH minus. For bases what happen? Concentration of H plus is less than OH minus. Simple common sense. Acid means which concentration is more? H plus concentration is more. Base means which concentration is more? Hydroxide concentration is more. That means H plus concentration is less. Very clear? So with respect to one particular concentration, always easy for us. So that's why always for acids or bases you please consider H plus concentration, so that you can write what is OH minus concentration also. Suppose X has H plus concentration is 10 power minus 2. Therefore what is the concentration of OH minus? 10 power minus 12, because both should be 10 power minus 14. Here H plus is 10 power minus 4. So what will be the concentration of OH minus? 10 power minus 10. So OH minus concentration will be more for weak acid. Okay. OH minus concentration is less for strong acid. Any confusion? No confusion. That's why better to follow only H plus concentration. Certainly you can write OH minus concentration easily. So for X, H plus concentration is 10 power minus 2. For Y, H plus concentration is 10 power minus 4. So H plus concentration is more here. So X is strong acid. That's it. Very simple. Why to write OH minus again? If they ask, automatically you can write. So this is about for acids. Same way you can write for bases. So as I said, all at one place you can write now. So these are very important. So concentrations from, you can write 10 power minus 1 to 10 power, this is acidic, right? 10 power minus 1. Okay, H plus concentration I am writing. 10 power minus 1, 10 power minus 2, 10 power minus 3, 10 power minus 4, 10 power minus 5, 10 power minus 6, and then 10 power minus 7. Now from 10 power minus 7 to 10 power minus 8, 10 power minus 9, 10 power minus 10, 10 power minus 11, 10 power minus 12, and 10 power minus 13, and 10 power minus 14. 10 power minus 14. So if concentration of H plus is exactly 10 power minus 7, the solution is a neutral. From 10 power minus 1 to any value actually, even 10 power 0 to 10 power minus 1 also comes under very strong acid. Okay, very much strong acid. So 10 power, in this way, as the concentration of H plus is decreasing, then acidic character, what happened? Decreases, I said. If the concentration of H plus is changing from 10 power minus 8, of course, as I said, here to here acidic and here to here basic now. So in this way, what happening here? Concentration of H plus, what happened? Decreased from 10 power minus 8 to 10 power minus 14. Here even H plus concentration decreased, that's why acidic character decreased. But here from 10 power minus 8 to 10 power minus 14, these H plus concentrations we consider as bases. Understanding? So H plus concentrations are less. So here in this way, what happened? Basic character, basic nature otherwise. Okay, basic nature increased from 10 power minus 8 to 10 power minus 14. As I given now x and y, some a and b you can compare. So a is a base, okay, b also base. Here H plus concentration for A it is 10 power minus 9, and for B H plus concentration is 10 power minus some 13 like this. So H plus concentration given like this, okay, greater than 10, less than 10 power minus 7, that means they are basic. Now who is strong base? If you see, who is having very less H plus concentration, that is strong base. So this is strong base. Otherwise first acidic character you can say. But the values are less than 10 power minus 7 no. These are less 10 power minus 7. These all are less than 10 power minus 7. Those are bases. So have very less H plus concentration, that means that have more OH minus concentration. So here for B, what is the OH minus concentration? OH minus concentration is 10 power minus 1. Here what is the OH minus concentration? OH minus concentration is 10 power minus 5. Total 10 power minus 14. So here OH minus is less. Here OH minus concentration is more. That's why B is strong base. That's it. Okay. So this is about acidic character and basic character. Why you are telling like this means maybe they can ask by giving concentration of H plus or by giving OH minus concentration, they can ask you who is strong acid and who is weak acid like that. Very, very important. Please note it down. Okay? Please note it down. Okay, sir? Thank you. Now, we have to discuss about a pH by having full clarity about all these things. Okay? So, everybody knows what is a pH. It is the measure of strength of acid or base. So given substance, by knowing the pH value, we can say that is a weak acid or strong acid. If that is a weak base or strong base, we can say by knowing pH value. So pH definition, if you want, pH is equals to its negative logarithmic value of concentration of H plus to the base 10. So this is pH actually. pH is equals to minus log concentration of H plus to the base 10. This is pH. Got it, sir, clearly? Now, same way, you can write POH. It's minus log concentration of OH minus to the base 10. Like pKa, it's minus log Ka to the base 10. Same way, pKb, it's minus log Kb to the base 10. Like this you can write. What are Ka and H and OH means you know? H plus concentration, OH minus concentration. That's why when you are considering H plus concentration, the term is called pH. If you consider OH minus concentration in logarithm for negative logarithm, that is POH. If you are considering acid dissociation constant, that is pKa. If you are considering base dissociation constant, that is pKb. So Ka is acid dissociation constant. Kb means it is base dissociation constant actually. So dissociation constants, okay, that depends on how acid actually, okay, how acid is dissociating and how base is dissociating, we will come to know from the Ka value and Kb value, remember, okay. So it's very very important. So as I said in previous, now pH values you can write pH plus pOH, totally you will have 14. Got it clearly? pH and pOH sum will be 14. Here it's not good. pH plus pOH is equal to 14H. Okay, in this way you can write. Okay, now what you can write? The values of pH and pOH from 1, 2, 3, 4, 5, 6, 7. So what these are? pH values. Okay, now 8, 9, 10, 11, 12, 13, 14. Okay, so pH exactly 7 is a neutral actually. As the pH value increases, then acidic character decreases. As the pH value increases from 8, of course, from 8 and between 7 to 8 also comes under bases. Of course, almost neutral, like 7.1 now, like that neutral, but slightly basic. That's the meaning. So in this way, after 7, if pH increasing, then basic nature increases. Very very important. Okay. So here I'll write one important thing for you. As H plus concentration increases, then pH value decreases. That means acidic nature increases. This is important. Okay. Similar way, concentration of OH minus increases, understanding, then or H plus decreases, both are same. Okay, you want in that way, if concentration of H plus, if better with respect to H plus, if you know it's better, why to have both H plus and OH minus, you may confuse. If H plus concentration is less, then pH is increasing. pH increasing means basic character increases. pH increases, basic character increases. Sir, I want to learn with OH minus concentration. Sir, I like OH minus means your choice. Ulta you have right. Ulta. Okay. Like instead of pH, pOH. As concentration of OH minus increases, then what happens? pH same. Ulta you have right. Concentration of OH 10 power minus 12 and 10 power minus same 10 power minus 14. These are what concentration of H plus. In this way you can say here pH will come 12, here pH will come 14. So 12, 14. H plus is less. That means OH minus concentration is more. Okay. So that's it. Very clear. With respect to H plus we written. Okay. So that no need to confuse. Okay. And same way as Ka increases, pKa decreases. pKa is less, then acidic character is more. Same way, Kb value increases, then pKb value decreases. pKb value decreases. Understanding? But this is base, so that basic character increases. Okay? So don't think this is reverse, because it is Kb value. It is not here. Why sir you written opposite? Means here both are H plus for acidic and basic. I written H plus concentration only. But here Ka value and Kb values I was taken. Same. Ka value increases, pKa value decreases, because it is a negative logarithm. No, negative logarithm. Okay. So it's very very clear. For a particular substance, anything for particular acid, H plus is a 10 power minus 4 given, then what is pH means? No need to calculate actually. Here what number you have? Only number. What number you have? 4. So pH is 4. Okay. So concentration of H plus is 10 power minus 12. Then what is pH? 12 only. What the number you have? That is a pH. Here 12. So pH is 12 means what is pOH? pOH is 2. So pH is more. Here pH is less. So this is base, this is acid. This is almost a strong base. So because pOH is less. So that is also clear. H plus concentration I written. So you can write with respect to OH minus this time. OH minus concentration increases, pOH decreases, then basic character is more. With respect to OH minus character. This is with respect to H plus concentration. Okay. So you can characterize a particular substance by using H plus concentration or else OH minus concentration. See, OH minus concentration is more, pOH is less. Very simple, sir. pOH is less means pH is more or not. So pH is more means that is basic or not. No need to confuse. Okay. So this is about what? pH. Please write it down. All these things. Now we will discuss about some important way to solve numericals actually. Okay. So only that way, if you know, like here logarithms and anti-logarithms, like if you learn easily, so that you can solve numericals easily. So if you see a pH, what is pH? It is a negative logarithmic value of concentration of H plus to the base 10, right? Then what is the concentration of H plus? Concentration of H plus is 10 power minus pH. 10 power minus pH. Concentration of H plus is equals to 10 power minus pH. Same way, concentration of OH minus is equals to 10 power minus pOH. You can write remaining also. So if they ask pH, no problem, we can use directly this formula. So pH is equals to minus log concentration of H plus. Correct. So to calculate these, okay, directly logarithm values, if you know, you can say what logarithmic values. Log 1 is 0, base 10 is very important. Log 2, everybody knows it is 0.3010. One digit when there, 0 point you have to take. Log 2 means one digit, no? Then 0 point. Okay. Log 3. Okay. Now 0.4778. So 48 you can take. Log 30, if they ask 1.48. 2 digits, no, in 30. 3, 0. 2 digits. Then 1 point here. When you have 4 digits, 3 point something is the answer. For a particular number. Okay. For this particular number, you have to see logarithm. Even log 254 like this also, no problem. So log to the base 10, here 1, 2, 3, 3 digits, so 2 point. Log 250 means almost between these two will come. 200 means 2.3. Log 300, 2.48. So between value you will have this. Understanding, huh? Log 200, 3 digits, so 2.3010. Log 300, 2.48. So 250 will come between 200 and 300, no? So it is like 2.42 or 43 or like that you will get. Understand? In that way, in a simple way, you can have logarithmic values. Very, very important. Okay? So here everybody knows like this. Log 4. Log 4 means 2 square. 4 means 2 square, no? 2 into 0.3. So 0.6. Log 5. I don't know. But I can take as 0.7 like that. Log 6. Log 2 plus log 3. Because 6 means 2 3s are no? Log AB formula. Log A plus log B. So these two if you add, you can get log 6. That means 0.78 like this. Log 7 you can have, log 8 you can have. Log 8 means 2 cube. 2 cube means into 3. So 0.9. So it's 0.84 something in middle. Like log 9. Log 9 means log 3 value, 3 square. So into 2. So 0. Almost 0.94 something. Okay, into 2 na? 967. Okay, approximately. Log 10 base 10, it's 1. Sorry, 1. Why you are giving these values? Because if you know this, by giving concentration of H plus, they will ask pH. So that if you know these values, so that you can find pH, right? Correct or no? Suppose here concentration of H plus is some 2 into 10 power minus 4 given like this. Then what is the pH if they ask? Remember, then pH is equals to minus log 2 into 10 power minus 4. Then what you will do, simple way I will tell you. Don't write log, okay, this is A, this is B, log A plus B. Okay, so log minus log 10 power minus 4. So log A power n log A, not required all those things. So of course those are required, these all. Log A power n means n log A to the base 10, all these things. So minus of minus plus 4. So when they are asking like this, first what power you have here, just forget about this negative, because minus of minus, that will become positive. So what power you have that you write down 4 first, minus, next remaining minus log 2, that's it. Log 2 value 0.3. Simple, no need to write many steps. So 4 minus 0.3010. Okay, very simple like this. Concentration of H plus, you have some 4 into 10 power minus giri. Something you have. First you have to write giri first. For what? pH. For pH, what is required? First this power, giri minus log 4. Okay, for log 4 you have to write giri minus 0. Log 4 0.6. Giri minus 0.6. How much? Can you see? You cannot. Sorry. Okay, so this is about pH, how to calculate. Understood, sir? Now, how to have anti-logarithms? Because by giving pH, now if they are asking H plus concentration, then anti-logarithms requires. Please write it down all these things. Okay, thank you. Now, oh shit, I want these values badly. Shit, again I have to write. Okay, but you written already. Those values are very, very important for us. Okay, so pH you have minus log concentration of H plus. If concentration of H plus, if they are asking, then I told you that 10 power minus pH, right? Okay, then what you have to do, 10 power minus pH means, suppose with example I tell you, pH is 4.6. Okay, then what is concentration of H plus? They are asking. Simple example I am giving. Then what is the concentration of H plus according to this formula? From this formula, it's 10 power minus 4.6, right? Okay. Now you know all the values already. Concentrations, sorry, pH values you know already. So here the most important thing. I'm getting allergy actually. Sorry for the disturbance. Now what you have to do is, this 4 you have, this before decimal will start as 4.6 or 6.4. 4.6. So 4 you have to think, 4 will come as like before value we will say na? So before decimal what you have here? 4. So this value increase by along with the negative. This value increase by one number. Then what you will have? 10 power minus 5. Understanding? 10 power minus 4.6. This minus 4, just 4 next number is 5. Along with the negative you have to write. Correct? Now 0.6 remains. Now that 0.6 subtract from 1. This 0.6 subtract from 1. This minus 4 increase by 1 number. So 4 next number 5. So minus 4, so minus 5. So now 0.6 subtract from 1. So that comes as anti-log of 0.4. Why I written anti-log of 0.4, understood? So anti-log of 0.4. Why 0.4? Since 1 minus 0.6. So this is concentration of H plus. So 1 minus 0.6 means you are having 0.4. Got it clearly? In this way, if you see anti-logarithms, then you will get H plus concentration easily. So very clear? What to do? This minus 4, just next number. Anti-log of 0.4, how you will get? Okay? Minus 4 next number, 10 power minus 5. 0.6, what you have to do? Subtract this 0.6 from 1. So 1 minus 0.6, 0.4. So you know these values. Log 2 is 0.3010. So log 3 value, it's 0.48. So what is 2? 2 is equals to anti-log of 0.3. Correct? Huh? Log 2 is 0.3. So 2 is equals to anti-log value. Okay? Anti-log of this 0.3 is 2 because opposite. Reverse. Now 3 is equals to anti-log of 0.48. So you can guess what is anti-log of 0.4 now. Anti-log of 0.4 now almost 2.5. So 2 is anti-log of 0.3. 3 anti-log of 0.48. So anti-log of 0.4 means between 2 and 3. So 2.5 into 10 power minus 1. This is the final answer. This is concentration of H plus. Very, very important. Got it, sir? Very simple. Now they are asking question like this. Example 2. pH is some 8.7. 8.7. Then what is concentration of OH minus if they are asking? Concentration of OH minus if they are asking. Then don't do directly 10 power minus 8.7. No. OH minus when asking, POH is required. What is POH? POH is equals to 14 minus 8.7. Then what is POH? POH is equals to, I think, 8.7, no. So almost 14 minus 9 means 5. So it's, I think, 4.3, right? 4.3, wrong. Okay. So 14 minus 9 means 5, no. So 4.3 and 8.7. 5.3, what's the 3? So 8.7, 4.3. How much? 3, 0, 1 to 13. So it's 5 point. Okay. Yeah. 5.3. 5.3. So please excuse me. POH is equals to 5.3. I'm weak in maths. That's why I'm doing like this. So okay, process understanding. So I'm giving important trick or not for you. Please consider all those things. Then what will be concentration of OH minus? Concentration of OH minus means 10 power minus 5.3. Correct? Correct? Okay. So minus 5.3. Okay. Now what you will have here? Concentration of OH minus. Same story. What I said is 5 increased by one number. So 10 power minus 6. So remaining anti log of 1 minus 0.3, so 0.7. Why I written 0.7 understood? 1 minus 0.3, so 0.7. 14 minus 8.788, I got POH 5.3. Okay, so concentration of OH minus is 10 power minus 5.3. This number increased by 1, so 10 power minus 6. 5 next number. Don't forget negatives here, because one of the option they will give plus 6. Okay, anti-log of 0.7. Everybody knows what is that. Log 4 is 0.6. Log 5 is almost 0.7. So 5 is equals to anti-log of 0.7. That's it. So you can write 5 into 10 power minus 6. This is one of the most important thing you have to consider. Okay, so it's very important. H plus concentration is more for what? Acids. pH is less for what? Acids. H plus concentration is more for what? Bases. That means pH is more for bases. If you want OH minus, same story, you can say now. Okay, so this is about what? pH and all. Okay, this is the most important thing, and how to have anti-logarithms. So few may think, so why you are explaining this much? Means I cannot compromise by saying all those formulas actually. So I want to give you the best way to answer all kind of numericals. That's why I said this anti-logarithms. Of course, we had this in previous, but you must have a revision. So we call this as revision. Okay, so you must know all this. Next is buffer solution. Buffer solution means what? The solution which resists the change in its pH even you add small amount of strong acid or strong base. That is called buffer solution. What is a buffer solution? Sorry, the substance or the particular solution which resists the change in its pH even you add small amount of strong acid or strong base. That is a buffer solution. Means when you are adding strong acid, so H plus concentration increases. When you add OH minus, means base added, then OH minus concentration increases. But pH will not change. But for certain extent, that's why we call, if you observe definition, buffer solution means the solution which resists the change in its pH even we add small amount of strong acid, small amount of strong acid or strong base. So unwantedly if you add bulk amount, certainly pH will change. But buffer solution can resist its pH, means cannot change its pH if you add small quantities of strong acid or strong base up to its capacity. Got it? That is called buffer solution. Buffer solutions are two types. One is acidic buffer and another is basic buffer. Acidic buffer means it is the mixture of weak acid and its salt. Its salt of strong base. Means weak acid when combined with a strong base, one salt will come, no? That salt and that particular weak acid mixture we called as acidic buffer. Example, CH3COOH plus CH3COONA. How you got this? This substance, how you got? This CH3COOH combined with NaOH, then you got CH3COONA. So this salt and this particular weak acid, okay, mixture we call as acidic buffer. Got it, sir? Many examples like H2CO3 plus Na2CO3 is a buffer, acidic buffer. Weak acid and its salt. How you got this? This carbonic acid combined with sodium hydroxide, NaOH. Then you got Na2CO3. This is about acidic buffer. Second one is basic buffer. What is this? Basic buffer. What is a basic buffer? same ulta ion, weak base and its salt of strong acid ulta. So this is very very important for us. Understood, sir, everyone? This is about what? Basic buffer or acidic buffer? Basic buffer. Okay. So any kind of example you want? NH4OH, weak base and its salt like NH4Cl. Maybe NH4 twice SO4, ammonium sulfate you can take, not a problem. So this is about basic buffer and acidic buffer. What is buffer solution? The solution which resists the change in its pH even you add small amount of strong acid or strong base. That working of acidic buffer and basic buffer I told you. Please remember all those things. Very simple. When you add strong acid, the added H plus ion will remove as water. Okay. Added H plus ion, removed as that CH3COOH. Very very important. If you add base like OH minus, then removed as water. That's why there is no change in its pH. What I said now you understood? Maybe not. Listen carefully. When strong acid added to this acidic buffer, suppose, then strong acid means H plus concentration you are adding or not. That H plus concentration will combine with CH3COO minus, means removed as CH3COOH. Got it? Very clear. So I will write here for acidic buffer, like what? Example CH3COOH plus CH3COO Na. For this, when you are adding H plus strong acid added, then what happened? If strong acid added, then what happened? Then added H plus ions combines with your CH3COO minus. CH3COOH is weak. CH3COO minus is strong. So the added H plus ion combines with CH3COO minus. So and removed as CH3COOH, which is weak acid. Weak acid cannot dissociate easily, so there is no change in its pH. So what I written, please read once again. For acidic buffer like this, if strong acid added, then added H plus ions combines with CH3COO minus. You may have a question, why sir? Why added H plus combines with CH3COO minus? Because the CH3COO minus is a strong conjugate base. Because CH3COOH is weak, so CH3COO minus is strong conjugate base. So the added H plus ion removed as CH3COOH. So that is weak acid. So there is no further H plus concentration increase. So there is no change in its pH. This is about working of acidic buffer. Sir, one small thing, sir. For this acidic buffer, if you add strong base, what happened? Then OH minus concentration will remove as water. So simple, that point also I will add here. For acidic buffer, if strong base added, then added OH minus removed as water. These 2 points, maybe they can ask, that's why I am giving theory questions. For acidic buffer, when you add strong acid, that removed as weak acid. For acidic buffer, when strong base added, removed as water. OH minus you are adding, combines with H plus, so removed as water. Sir, what is the working of basic buffer? Tell me, sir. I won't say, just reverse. Means for basic buffer, when you add strong acid, removed as water. For basic buffer, if you add strong base, then removed as weak base. Very clear. I will tell you those very clearly. So you please write it down all these things. Okay. So it's very clear. Please have a screenshot and write down. So working of acidic buffer I told you. So the working of basic buffer also you can have. So at one place you can have all those things. I will write for acidic buffer. I will write 2 points in a small box, in a small bracket box. If strong acid added, then added H plus, remove as weak acid, any weak acid. Clear? If second point A and B, if strong base added for whom? For acidic buffer, I am telling all these things. Then added OH minus ions concentration, removed as water. Clear? Ulta, same box you write for basic buffer. For basic buffer A, if strong acid added, getting what I am saying? Okay. This is for acidic buffer. When you add strong acid, what happened? For acidic buffer, when you add strong base, what happened? Directly. For basic buffer, if strong acid added, then added H plus concentration, removed as ulta. Ulta means here weak acid, no? So here water. Understand? Ulta. For acidic buffer, when you add strong acid, removed as weak acid. Very simple. For acidic, when you add base, what happened? Neutralization, water. For base, when you add acid, what happened? Water. That is the trick. I repeat. For acidic buffer, base added, water, neutral. For basic buffer, strong acid added, then removed as water. Clear? Theory questions very important. Same. If strong base, basic buffer, base, no water. Okay? Strong base added, then added OH minus concentration, removed as weak base. A weak acid, removed as weak base. Clear? Small trick how to remember. For acidic buffer, when you are adding strong base, removed as water. For basic buffer, when you add strong acid, base acid, basic acidic water. Like that. So in this way, you can have full clarity about how acidic buffer works and how basic buffer works and why the pH won't change. But this is up to its buffer capacity. Okay, so very clear. Now, what is the pH of buffer? Henderson equation you have. pH of buffer. pH is equals to, for acidic buffer I am telling, pH of what buffer I will write here first. pH of acidic buffer. pH of acidic buffer. What is the pH of acidic buffer? pKa plus log concentration of salt by concentration of acid. What acid? See acid how I written like a stupid fellow. Acid. Base 10. Weak acid will be there no in acidic buffer. That weak acid concentration. So pKa means everybody knows minus log Ka. pKa means minus log Ka. You can write or else pH is equals to pKa plus log N salt V salt by NaVa. What is N? N salt, V salt means for salt normality. Salt normality and volume. Understanding? What is V salt? Sorry, what am I? NaVa. NaVa. This is acid normality, and acid volume. The same can you write for basic buffer? You can write. What is pKa? Everybody knows pKa. pKa is equals to minus log Ka to the base 10. Same pH of base buffer. Tell me pH of basic buffer. But pH directly you cannot get for basic buffer, because basic means OH minus concentration. How you can take pH directly? No. For basic buffer, first is POH. POH is equals to pKb plus log N salt V salt by NBVB. You can write like this also. Concentration of salt by concentration of base here. Not required. So mostly we use this. Okay, when volumes are same, then volumes will cancel here if they said. Okay, then pH, if they ask 14 minus pOH. This is pH of basic buffer. Very, very important. Please make a note all these things, and very simple. Next our chapter is redox reactions. Along with that, I will complete the salt hydrolysis as well as solubility product. Only two concepts, just 15 minutes time. Okay, oxide redox reactions, however, it is very less. Okay, it's a very small concept. We can complete those, don't worry, in our next class. Hope you understood all these things. As I said, if definitely required, not definitely, pakka, I will take 1 or 2 extra classes so that you can watch those later, so that first year revision will complete effectively. That's what I am trying actually. So don't worry and don't think about anything else. Just go through these videos, watch carefully. If you have any doubts, revise, and still if you have any doubt, just ask me, I'll explain. Okay, take care once again and prepare properly. All the best, and write down all these things. So based on buffer solutions also, numericals you will get.